Hello, welcome to EarthView Remote. I am Dr. James Hayes-Bohanan, one of the members of the EarthView team from Bridgewater State University. As many people know, we usually take our inflatable globes or large National Geographic floor maps to schools in special programs all over Massachusetts and indeed around the world. During this time where we're mostly studying and working from home, we're trying something a little different, which is to capture some of the idea of EarthView, which is exploring the world from our desktops. So I'm going to be sharing one of my favorite maps with you, and hope that you enjoy learning about the world in a slightly different way for a moment. So I'm going to open a screen. And where I'm taking you is to the EarthView blog and to an entry on the EarthView blog called Earth at Night. And from there, you can the link to this will be included under the YouTube video, and you'll be able to come back to this and explore this map on your own. But I want to show you how I look at the map first. And the map is called the Astronomy Picture of the Day from November 27th, year 2000, and often called Earth at Night. So this is a map that was assembled by NASA, or an image from NASA and some of its partners, NOAA, the National Oceanic and Atmospheric Administration, and a few other partners. And you can read a lot of technical details here, but I like to just look at the world this way. And so we open up the map, and indeed it will start with this view and showing the whole planet. And the first question I ask when I show this to my own classroom at Bridgewater State, I use this in a variety of classes that I start with. So what was going on this day, November 2000, that made the whole Earth dark at the same time so that we could see the lights? And inevitably somebody, I asked the question, so there must be an answer, right? So people guess maybe it was an eclipse. What appears as a solar eclipse is a good guess, because the solar eclipse does put a shadow at a time of day you would not expect it. But if you think about it, the solar eclipse projects a dot onto the planet, and that is a moving dot. I'm actually going to include a link to my own experience of a solar eclipse in the year 2019, in which I had to go to Chile to observe it. I could have also seen it from Argentina. Eclipses are usually visible only on a small portion of the planet. And in fact, at any one time, I did a little math and figured out that an eclipse is typically about the size of Massachusetts and Connecticut combined. Southern New England and Rhode Island. That's about the size, or half the size of the US state of West Virginia is what a typical eclipse is. So that's not what's happening here with this image. Indeed, what's happening with this image is some satellites that are used for the weather and fly at about 800 kilometers above the surface, or 500 miles above the surface, constantly gathering data for weather forecasting. Were stitched together. Images from that taken at night. Those are both day and nighttime images. They took the nighttime images over a period of months and selected some, and then because they know the location of each image, they were able to stitch them together. That process of stitching images in geography, we call that making a mosaic. And so this is not a single image, but rather a mosaic of a few thousand images of the world. An interesting thing about doing this is that, remember, the whole purpose of the satellites is to track weather. And so quite often they're showing clouds. And this is an image in which they selected some cloud-free nights in order to stitch together this image. And it shows where the lights are on around the planet. And I'll just start with a real general overview. It's a flat projection, so unlike the globe, there has to be a cut somewhere. We can see the Pacific Ocean in the North America, South America. We can see Greenland kind of faintly at the top. It looks huge because of this projection. Then we have the Atlantic Ocean. We see Antarctica at the bottom, also looking huge because of the projection. And then we have the continents of Africa, Europe, Asia, and then Australia. And then, of course, a lot of islands. Some islands show up better than others. The US island archipelago collection of islands known as Hawaii is pretty easy to see out in the middle of the Pacific. So that's a basic orientation. What this also shows us in general is population. We call this a proxy map. It is not a population map, it's a map of lights. But where there are humans in the year 2000, as today, wherever there are humans, there are probably some lights on at night. So if you're mapping lights, you're mapping humans to some degree. We call that a proxy, where we map one thing representing another that's highly correlated. But as we'll see, there's a little bit of a risk of doing that we don't capture everything. It's not exactly a population map. But this is a good way to start talking about population. I encourage you to go and look at other population maps specifically to get more detailed information about population. But this gives us a pretty good view that around the world, there are some major centers of population. There is the eastern part of the United States, especially the Northeast. There is Europe. There is South Asia and East Asia. Those are the four largest population centers. And in fact, I went a little bit out of order in terms of the actual population, although I did kind of match the order of light being emitted. The greatest population cluster, as geographers call it, is in East Asia, including China, Japan, the Koreas, Taiwan. And next largest is the Indian subcontinent, or South Asia, which includes the countries of India, Pakistan, Sri Lanka, this island here, Bangladesh, Nepal, and Bhutan. With the majority of that, of course, being India, that Indian subcontinent. And then next is Europe, and then following that, the United States. Now, you'll notice the United States is a bit brighter in intensity than any of these others because we use a lot more electricity than most other parts of the world. And of course, there are large centers of population elsewhere. South America has something over 500 million people. I have not added that up, but more than 500 million people. And Africa, the continent, also has 1 billion people. And then between South Asia and East Asia, some geographers describe Southeast Asia, which includes Vietnam, Malaysia, Indonesia, and neighboring countries, as a fifth cluster in terms of its population. If we click on the map, we can get a little magnifying glass and zoom in just a little. We can't zoom in much further than this, but we can zoom in just a little bit and start to notice some patterns. And I like to do this as well with my own students. This is something we can't do in EarthView that I like to do with my own students. What we can see here is that if we imagine the boundary between Canada and the United States coming across about here, where I'm more running the cursor down around the Great Lakes. We can see the major population centers of Canada are all pretty close to the United States. And I say that's because they love us so much. And we do have good relations with Canada, but I think the main factor is that's the warmest part of their country is close to us, their southern edge. Within the United States, we see a number of patterns. One is that the Boswash corridor from Boston to Washington is highly populated, highly industrial and residential, and has quite a large portion of the United States population and quite a lot of light. We can also see that within Florida, most of the population is concentrated along the east and west coasts, and even along those islands down through the Keys. Another major population cluster in the United States, of course, is in California, and to a lesser extent up in the Northwest. We also have some strong light up in Alaska, which is one of our least populated states, but our largest state, some of that light is associated with oil exploration. Those settlements are not really that big. And of course, as I mentioned before, we have Hawaii, and then there's some other Pacific islands that do show up. Moving through what we call Middle America, through Mexico and Central America, we can see that the majority of population in Central America is along the Pacific coast. The majority of population in Mexico is in the Central Highlands, and Mexico is kind of an exception in that way. In most of the world, as we can see here, the greatest concentrations of population are near coastlines. This is because they have the most access for trade by ocean to other parts of the world, and also because along the coastlines we tend to have flat coastal plains, which have the potential for more fertile soil. Moving into South America, we see in the north part of South America, around Venezuela, there's a little exaggeration of light here in the oil exploring areas of Venezuela and Colombia. But in general, you can see the pattern that in South America, most of the population is near the coast, whether that's over in Chile or in Argentina and Brazil. Most of the population is in the coast, and that has to do with the original European settlement in South America was from the coasts for the purpose of exporting agricultural goods. They have tended to expand inward, but still the vast majority of human activity in South America is near the coast. We can also see, I skipped over the Caribbean region. We have the big island of Cuba, smaller islands here of Jamaica, Hispaniola. We can see both Dominican Republic and Haiti. And if you look at this image, you can actually see that the Dominican Republic has greater economic development and more lights on. This most brightly lit island is our own territory, the US citizens of Puerto Rico, and the lights are on there just as they are in much of mainland United States. And then we have the lesser islands, a group of a kind of a volcanic arc here of islands, some independent, some still territories of European or even US colonialism. I want to go back up to the United States mainland just to point out one thing, and that is on any map that we look at of the United States or of the world, we can see almost all the time the 100th meridian, which is meaning 100 degrees west of Greenwich, shows up on the map. In this case, it tends to be a bit darker to the west of that, brighter to the east. But it's true on almost any map of the United States that you can see some difference at the 100th meridian, whether it is population density, road networks, the size of states, the shapes of states, the pattern of roads, the pattern of railroads. And in this image, what we actually can discern, if you look at this on a big enough screen, you can actually see the remnants of the old railroad network across the western United States, which was very much more geometric than the railroad network in the east, and that's still reflected in the pattern of settlement in the western United States. And if you look at a map and you can't see that 100th meridian, that is also a geographic question is raised. Why wouldn't a particular map reflect that pattern? That 100th meridian, by the way, just happens to coincide with the 20-inch isohyet, or the 20-inch rainfall line. To the east it's wetter, to the west it's drier, and a lot of things are influenced by that, as well as by history. Okay, moving across the Atlantic, I want to show you that in Europe, a couple of patterns here. One is in the United Kingdom of Great Britain, in Northern Ireland and Ireland itself. We see that most of the population is toward the south certainly of the island of Great Britain. There's a much less populated area to the far north of the United Kingdom. More interesting, I think, around Europe is the fact that we have brightly lit outlines along the coasts, especially along the Mediterranean coast. these are areas that have been very popular for settlement for a long time, whether for trade, agriculture, or just for the beautiful views. Parts of Europe extend out into the Atlantic Ocean. We have the current possessions of, or current provinces of Portugal in the Azores and in Madeira Island, and both of those are the source of many migrants to Massachusetts. We also have brightly lit here the Canary Islands, which are part of Spain, and then a little harder to discern is an independent country that was once part of Portugal, the islands of Cape Verde, about 300 miles off the west coast of Senegal in Africa. Then in Africa itself, mainland Africa, as I said, this is about 1 billion people, and the lights are not quite as bright. In fact, quite a number of those people live in West Africa between Nigeria, Ghana, all the way over to Liberia. And in this area, the relative paucity of light means that this is an area where the proxy mapping does not work so well, because the amount of economic development, economic activity per person is less. And so we don't see quite how many people there really are in that part of Africa. There are also a great number of people in East Africa between Tanzania and Kenya who do show up on this map, but not nearly as brightly as their numbers would suggest. And then the wealthiest country of Africa is South Africa, and that is brightly lit here, not because its population is bigger than many of the other countries, but because the economic activity is greater per capita. And there are a significant number of people. There are about 6 million people in South Africa, and excuse me, there are about 20 million people in South Africa. And the greatest number of them are in the Johannesburg area. Another great feature to highlight on Africa is the North Coast does have a great concentration of population along the Mediterranean, as Europe does, all the way from Morocco and Algeria, Tunisia, all the way over to Egypt. And then in Egypt, we see one of the most remarkable things is that within Egypt, 95% of the people live along the Nile River. Coming over here to the Arabian Peninsula, we see what looks like a great deal of population. That's another sort of misallocation here of light, I guess you'd say, a lot of light for a relatively small number of people because, again, of oil exploration. And I've already mentioned the Indian subcontinent, which used to be attached to Africa and Antarctica back in the days of the dinosaurs. It was an island moving toward mainland Asia, and it is actually still moving a couple of inches per year. And the great rivers, river valleys, especially of India, the great soil fertility, makes this one of the world's largest populations. And then finally, we have China. Most of the people of China live in the eastern part, again, where the soil fertility is greater. Here's the island of Taiwan. Here is the main island of Japan, very brightly lit, very high level of economic development. And here's something that looks like an island, this round cluster here between China and Japan is South Korea. And it is not an island, but the economic situation to the north in North Korea is so, frankly, it's so bleak that there's very little light produced there. And you can almost only see, just barely, the capital city of Pyongyang is discernible there, but it is not very, very strongly lit. And finally, Australia. Within Australia, again, like some other parts of the world, the vast majority of people live in the coastal areas, including Tasmania, the island. I'm going to shrink this again so that we can, first of all, see New Zealand off to the side. And then I want to talk about one other kind of global pattern here that we can see. I've talked about where the population is. I just want to mention where it is not. There are not a great number of people in Antarctica. There are not a great number of people in the Arctic. These are places where some people do live, but very small numbers. All of those in Antarctica are there on research projects from various parts of the world. And there are indigenous people and others living in the far north, but in very low population densities. So the very far north, the very far south, very high elevation areas, such as the Himalayas here north of India, the China-India border area. You can't see it very well at this scale, but a lot of the Andes are similarly very low population density. They can be occupied, but just not by very many people. So there are some very cold areas, some very high areas. Also, the Amazon Basin, where I got my start as a geographer, has people. People can live there. People have lived there for thousands of years, but their numbers are relatively small because although there's a lot of rainfall, the soil productivity is very low, so it does not sustain agriculture at very high levels. Similarly, the Congo. An exception to this is in Indonesia. There are a lot of densely populated tropical rainforest areas, but that's pretty unusual. And then the fourth kind of area where the population densities are very low are the very dry areas of the Sahara, the Saudi Desert. Again, the light there does not reflect population, it's oil exploration. The Kalahari Desert in Southern Africa, the outback of Australia. An exception here again would be the United States. The western deserts of the United States are populated a little more densely because of the support of air conditioning and other technologies. But to summarize, the places that have relatively low numbers of human occupants, low population density, are those that are cold, high, wet, and dry. Places that are too hot are not necessarily unsuited to human occupation. Some places with high population density, such as the north coast of Africa, can be quite hot, but agriculture can be sustained, so therefore so can people. But in general, places that cannot support agriculture at a high density because of there being cold, high, wet, or dry don't have very many people as well. So thank you for exploring the Earth with me. Again, this is a map available on our blog, BSU EarthView, and this is an entry called Earth at Night. If you found this video, you'll find a link to Earth at Night below. So thank you for joining us for EarthView on your desktop, and we hope to see you in a classroom or gymnasium in the near future.